Welcome to the Just Ferries podcast. Today we are talking about the development and the construction of the ferry KARL CARSTENS for the German Federal Railway. In 1983, the wish of the Federal Railway Directorate in Hamburg for the construction of a new train ferry for the ferry line between Puttgarden and Roedby was presented to the management of the German Federal Railway, DB, in Frankfurt. In the same month, the management complied with this request and issued a planning order. Within the Federal Railway Directorate in Hamburg, a project group, New Ferry Construction, was set up. In cooperation with the Nobiskrug shipyard, which acted as an engineering office, the project group of the German Federal Railroad drew up a catalog of measures that were to be incorporated into the construction of the rail ferry. Added to this were the positive experiences made over the years in the operation of ferries. Difficulties arose with the main dimensions. An increase in capacity could only be achieved by increasing the values of length, oar, and width, oar and draft. The width was fixed at 17.7 meters, the draft at 5.9 meters almost. So the only alternative that could be chosen was to increase the length. 1957 built ferry Theodor Heuss, which was to be replaced by the new ship, was 135.9 meters long. The new ship was to be 164.68 meters long. This was the just permissible ship length concerning the maneuverability of the ship in the two ferry ports. The draft of 5.9 meters also dictated the future height of the new ship, as it was necessary to ensure a lateral ratio of underwater to above-water ship that was favorable for maneuvering. The technical components of the new rail ferry were to be as maintenance-friendly as possible. The following measures were developed. Annual underwater inspection of the ship's bottom instead of shipyard visits. Application of new paint coating systems for optimum corrosion protection. Design requirements for rapid engine replacement without shipyard visits. The choice of engine system should be based on the aspects of modern and future-proof drive technology. In particular, the following points should be fulfilled. Engine system with very high availability. Engine concept consisting of a diesel-electric drive and enabling economical operation. Possibilities also for operation with heavy fuel oil. State-of-the-art monitoring options for machine operation. These basic requirements of the preliminary design were all included in the tender specifications, which were submitted to a total of 10 interested shipyards in northern Germany. Taking all economic aspects into account, Kiel-based Howaldtswerke HDW made the most interesting offer and agreed to supply a rail ferry. The contract was signed in Kiel on November 23, 1984. HDW undertook to deliver a modern and future-proof rail ferry by May 2, 1986. During the trials at the Hamburg Shipbuilding Research Institute, the possible propeller types were examined in particular. The aim was to stop the ship with low vibration over a relatively short distance. In addition to good forward characteristics, the propellers had to have good reverse characteristics. After evaluating all the tests, the decision was made to use fixed-pitch propellers with 6 blades. The surfaces of the rudders, semi-floating rudders at the stern and a bow rudder, were adapted to the increased underwater lateral area and checked by maneuvering tests. The 2 stern rudders were each given 12.5 square meters of surface area and the bow rudder 21 square meters. The hull was welded entirely of steel and had built-in sectional construction. Longitudinal bulkhead construction was chosen from the railroad deck and higher for weight reduction reasons. Below that, the ferry was built using transverse frame construction, with the double bottom stiffened by floor stringers at each frame. Among the shipbuilding details of the vessel was the double bottom with water ballast, fresh water, and other tanks. Above this were engine rooms 1 to 4 and a 'tween deck with compartments for personnel. The railroad deck had 3 side-by-side tracks with the continental European gauge of 1,435 millimeters and was divided into 3 sectors by central shafts. The rails were recessed into the ground so that road traffic could be easily carried. Clearances for wagons were maintained at all points, one of the DB's main requirements. The side tracks had a maximum length of 153.09 meters, the middle track 152.6 meters. With the most favorable asymmetrical loading, 405.48 meters of usable track length became possible. A total of 2 trim tanks with 545 tons and 4 heeling tanks with 1,220 tons have been built. Finally, the 2 wastewater treatment plants should be mentioned. Great importance was attached by the designers to a good fender list. The reason can be found in the frequent mooring maneuvers on this ferry line. In the parallel part of the ship, the straight sides, a construction firmly connected to the outer skin was chosen. In the forward and aft tapered areas, an elastic rubbing fender list was installed. The entire engine area was planned based on a plastic model. The aim was to achieve a good overview, short distances, optimum operation of the equipment, assembly maintenance, and functionality. Each diesel engine of the type MAK 12M282 had an output of 2,400 kilowatts. In total, the engines were capable of running at 10% overload for 1 hour each in 12 hours. The entire system was designed in such a way that it was possible to change engines within the port lay time, which in this case was assumed to be 45 minutes for maintenance purposes. Since the ship was designed as a diesel-electric ferry, propulsion was provided by Siemens electric motors. 1 electric motor drove each propeller with a continuous output of 4,750 kilowatts. The 6 generators operated on a bus bar, which made it possible to start and stop motors in a targeted manner, depending on the power required. The overall layout of the passenger deck was to convey an open, large space and allow a good view of the water. Therefore, promenade-like areas were created. In the middle, on the other hand, the retail stores, cafeteria, or staircases were arranged. Partition walls within the ship were glazed, as far as feasible under the aspects of fire protection. The central level for up to 1,500 passengers was the passenger deck, which was divided into the hall, duty-free shopping zone, and catering areas. As a centrally located facility, the hall provided a total of 4 shore gangway openings, 2 for Denmark, 2 for Germany. In addition, there was the information area and smaller souvenir stores. The bank and a telephone system were set up to enable passengers to make long-distance calls to anywhere in the world. A handicapped accessible toilet facility rounded out the services offered to passengers in this area. The entire duty-free shopping zone was located in the aft section of the ship and featured a large duty-free supermarket and perfumery. Video equipment and additional seating completed this area of the rail ferry. All catering facilities were arranged in the forward section of the ferry. In addition to an a la carte restaurant with large panoramic windows facing forward, these included a cafeteria that operated on the so-called free-flow system. Customers could put together their meal in this area. According to the German Federal Railways, this free-flow system was installed for the first time on a ferry boat. On the boat deck, there was a conference center, as well as a kiosk, and the nautical facilities such as the bridge, officers' quarters, radio room, and crew mess. By the way, there was no launching of this ship. It was built in a dry dock and floated up on 17/01/1986. Only a few months later, on May 2, 1986, construction number 211 was christened and commissioned. Numerous guests, such as former Federal President KARL CARSTENS, his wife Veronika Carstens, and the Federal Minister of Transport, took part in the ceremony. Before the christening of the ship, the HDW director mentioned the very short time between contract award and completion of the ship. He emphasized the close ties between DB and HDW. It was a good opportunity to point out the difficult situation of the German shipbuilding industry to the politicians present. He went even further and said that what is granted to the farmer should not be withheld from the shipbuilder, namely subsidies. The shipyard boss expressed his gratitude to the Federal Railways. The order had averted the threat of underemployment. The christening by the wife of the former federal president took place on the name KARL CARSTENS. The ship left Kiel Harbor at exactly 11:05 to go on a presentation journey. Another presentation trip a few days later took the new ferry to Hamburg. The KARL CARSTENS made its way to the Hanseatic city of Hamburg through the Kiel Canal. As originally planned, the commissioning took place on 1/6/1986. The scheduled service between Puttgarden and Roedby could be started. This was the Just Ferries podcast about the development and construction of the KARL CARSTENS. If you would like to learn more about ferries, please visit justferries.de.